All right, so we're going to depart from sequences just for a moment and learn about a concept called a summation that we then can apply to our sequences in the next couple of lessons. So let's consider this function f of x, and it's a simple linear function, and we're asked to find the sum of f of 3, f of 4, f of 5, and f of 6. So what I want to do here is add all of those together. F of 3 plus f of 4 plus f of 5 plus f of 6. So I have to find these individually, and then I have to add them all together. So f of 3 is going to be 2 times 3 minus 4, plus f of 4, which is 2 times 4 minus 4. F of 5 is 2 times 5 minus 4, and f of 6 is 2 times 6 minus 4. Okay, so I can evaluate each of these now. 2 times 3 is 6, minus 4 is 2, plus 8 minus 4 is 4, plus 10 minus 4, plus 12 minus 4. And I can add all of these together, and I get 20. All right, so that wasn't too bad. That was pretty easy to do. But as it turns out, there's a mathematical function that we can use on our graphing calculators, on Desmos calculators, and on other calculation tools that make this process easier, especially when these get a little bit more complicated, and that's called a summation. So what I could have done here instead is used one of these summations to calculate the sum of terms 3 through 6 of this, and we're going to call it a sequence, right, of the sequence 2x minus 4. So the way that we're going to set this up is by using the Greek letter sigma, and you've probably seen this on your calculator or on some online calculators. And there's a couple bits of this that we need to be very careful of. I'm going to start by saying that x is equal to 3 is where we want to begin, and we want to end when x is equal to 6. And you might see these summations written with I rather than x, or some other variables, but it really just means what am I plugging into the variable first. So now my summation knows to plug in a 3, and then to plug in a 4, and then to plug in a 5, and then to stop after we've plugged in a 6, and to add all of those things together. But I first need to tell the function which function to plug these values into. So now I've told my function to plug in a 3 into this function and get a result, then to plug in a 4, get a result, 5 and a 6, get a result, and then add them all together like we just did. So what I'm going to do is show you how to do that on a Desmos calculator here. All right, so I just opened up the Desmos graphing calculator, which is what you'll want to use at home. And I'm going to go into here where it says functions. So over on the right, I have some options, and I'm going to cycle through these different menus. But in miscellaneous, you will find the Greek letter sigma. And this is where you can plug in what you need to. So starting with a 3, and then ending with a 6. And you can do a couple different things with this function. You can replace that with an x, which is what I'm going to do here. And then in parentheses, I'm going to put my function here, which was 2x minus 2. Or minus 4, rather. That was the function that we were given. And so when I plug that in, the calculator does exactly what I asked it to do, and it plugs in a 3, and then a 4, then a 5, and then a 6, and it adds them all together. And we got 20, and the Desmos calculator got 20, so this is how you're going to be using these on your own because you don't have the TI-84s at home. So essentially, that's how you use these summations to evaluate the sum of a number of terms of some sequence, or of just the value of the sum of plugging in a bunch of different integers into a function. So let's continue applying this concept. We're going to use a summation to find all of the values of the below function when x is an integer between 6 and 15. And our function is going to be g of x equals 2x squared minus 3x. All right, so we've got a quadratic function here. It's going to start to get a little bit more complicated now when we're plugging values in and adding them all together. So we're going to use the summation. It says to use a summation, so I'm just going to write out what I'm going to plug into my Desmos graphing calculator. And I'm going to start by plugging in a 6 because it says all the integers between 6 and 15. So 15 is where I'm going to ask the function to stop. And then I'm going to plug in the function 2x squared minus 3x into that summation. So this whole thing is going to go into my Desmos graphing calculator, and I would encourage you to pause this, try to do it on your own, and then make sure that you've done it the way that I do it so that you get the correct answer. Okay, so hopefully you've already done this on your own, and I'm just going to open up the functions menu, grab sigma. I am going to turn this into an x, and I'm starting at 6 and ending at, what did we say we're finishing this at? 15 is where we're going to stop. And I have to make sure that I plug in the correct function here, which is 2x squared minus 3x. So this would have taken some time if I had done it by hand because it's a pretty large number. So if I plug in a 6 and then a 7 and then an 8 and all the way up to 15 and then I add all those together, I get 2,055. So it's important that I showed how I wrote my sigma function out, what I plugged into my calculator, because obviously the calculator is doing most of the work for you here at this point. But once I've done that, I can just put my final answer here. All right, the last step of today's lesson is we're given a function, and it serves a purpose. It says that this function models the number of flies that are born in a garage as a function of time t, which is in days. So it looks like this is some sort of exponential growth function. And if I plug in a 1, that'll tell me how many flies were born on day 1. If I plug in a 15, it'll tell me how many flies were born on day 15. So the question is, how many flies were born in the first 12 days? So what this is essentially asking is, I need to calculate the number of flies that were born on day 1, and the number of flies that were born on day 2, and the number of flies that were born on day 3, and day 4, and day 5, all the way up to the 12th day. And I know that I have a much better way of doing this than to actually calculate these all by hand. I'm going to use my summation, and I'm going to say to start when t is 1 and end when t is 12, and I'm going to use the function 13 times 1.41 to the t power and ask my graphing calculator what this comes up with. So once you've evaluated that in your Desmos graphing calculator, you should end up with 2,715.92. You could look at this a couple of different ways. I'm going to say that this is approximately 2,716 flies. However, you could look at this from the perspective that 0.92 flies is not yet a fly. So if you wanted to go with 2,716 here, that would make a whole lot of sense. All right, the last part of this lesson is we're going to continue this question and say how many flies were born in the first 12 days, excluding days 4 through 8. So there are a couple of different ways that we could approach this, and I'm going to write this out as a summation, just thinking about how I'm going to approach this first. Let's say that I want to use the number I have right now, which is from t equals 1 to 12 of my function f of t. Well, this would be days 1 through 12, and they said to exclude days 4 through 8. So what I could do is take the number I have right now and subtract the summation of the elements of days 4 through 8. And that's one valid way to do this. A couple other ways, or another way that you could do this is you could say, well, let's add up days 1 through 4, or through 3, because I don't want to count day 4. And then I'm going to skip 4 through 8 and pick up and add together the terms starting at 9 and adding at 12. Either of these is a valid way to approach this. They're the same exact thing. But essentially what you're saying is I have days 1, and I'm just going to pause and write all these numbers. I have days 1 through 12, and this way over here on the left, and I'll just do this in yellow, this is saying let's add all of these up and then subtract these, right? And then that's going to leave me with days 1 through 3 and days 9 through 12, and I can add those together. And then the way on the right, which is the same exact thing, is saying let's just add these together and then add these together. But either way, I'm still going to end up with the whole. So the point of this exercise is just for you to see that you can work with these summations and not necessarily just add the first 12 terms or the first 100 terms. I can add just chunks of a section of a sequence, And I could subtract those chunks just like I do subtract any numbers or integers or any other type of number. So let's actually calculate this here then. I'm going to choose to approach this with the left-hand side of the equation because I already have this number, this 2,715.92 repeating. And so I'm just going to subtract this summation here to give me my final answer. And so hopefully you try that on your own, but the value you should get is 2,142.801. And so I'm going to say that that's approximately 2,143 flies. So there are a number of reasons why I might have wanted to exclude those days. If this data is more meaningful than flies, maybe it's the growth of stocks or some sort of investment over time, and there was something weird that happened over those days, and you want to throw those days out because it's an outlier, or something else that's going on, and you only want to look at certain sections, then we can use these different summations to do that. So we're going to be using these summations eventually to apply them to sequences, but right now this is just the basic idea behind using this sigma function.